Hello viewers on YouTube. In this video tutorial, we are going to consider the quotient rule of derivative. Hopefully, at the end of this video, you will be able to prove and see the basic idea behind the quotient rule of derivative. So let's begin by stating what it is. Okay, it says that if y is a function and it's equal to f of x, and this f of x is equal to the quotient of two other functions, u of x by v of x, then the derivative of y, which is denoted as y prime, or the y dx, or f prime of x, is equal to the function at the denominator v of x multiplied by the derivative of that of the numerator u prime of x, then minus the function at the numerator u of x multiplied by the derivative of the one at the denominator v prime of x, then everything entirely divided by the square of this v of x all raised to power 2. Perfect. So this is what says the quotient rule. But let's take into account how this rule is formed. To prove it out, we are going to consider using the definition of derivative. So let's begin. To form the definition of derivative, if y is equal to f of x, then the derivative dy dx is indeed equals to the limit as h approaches 0, where h is the change in x or delta x, okay, of f of x plus h, the minus f of x, all divided by h. Now, back to this. If f of x is equal to this, then what would be f of x plus h? So in this case, f of x plus h, which simply means whenever we see x, we should replace with x plus h. This simply equals to u of x plus h divided by v of x plus h. Perfect. Now that we have f of x and f of x plus h, we can substitute them respectively right in this first principle formula. Okay, perfect. So now we have the y dx to be equals to the limit as h approaches 0 of f of x plus h. We got that to be this, that's u of x plus h divided by v of x plus h, the minus f of x, that is this, that's u of x divided by v of x, and everything entirely is divided by h. Okay. Now as you can see, this is a compound fraction. Let's simplify it by the method of keep, change, and flip. So let's rearrange it first. Okay, let's convert this number line division into a regular one. So to have enough space, I think this should be enough. So let me just roll it down. Okay, so now we have the y dx to be equals, okay, to the limit as h approaches 0. So now I'm trying to turn this to the regular division symbol resulting use. So we have u of x plus h divided by v of x plus h, the minus u of x divided by v of x, then divided by h. That's just divided by h. Okay, perfect. Now, simplifying forward, should I keep on writing this? Let's just continue. The limit as h approaches 0, okay, then we are keeping this first fraction, that's u of x plus h, divided by v of x plus h, the minus u of x divided by v of x, then we have to change this sign to product times, then we flip this one over h. Okay, so now what I will do next is that I want to keep on writing this just like equal sign. Okay, now that it's the same. Perfect. Now we have the limit as h approaches 0. All right, now I would like to combine these fractions as LCM. You understand? Let's combine them. So if v of x plus h times v of x is the LCM, then what will be the corresponding numerator? Now for this and this left over is this. If we multiply with this, we have u of x plus h times v of x. Perfect. Now the subtraction sign is still there, minus. So let me just put 1 over h times 1 over h. You can see that in minus, now v of x in this entire expression is left over with v of x plus h. So we have v of x plus h, then times u of x. Perfect. Now, simplifying forward, we have the y dx be equals to the limit as h approaches 0. Okay, so what I will do instead is that I'm taking this away from this entire fraction, but not out of the limit. Okay, just see what I'm doing right there. So I'm having 1 divided by v of x plus h multiplied by v of x. So I'm leaving the h under the numerator. So multiply by, so we have u of x plus h, okay, times v of x, the minus v of x plus h times u of x. Okay, all divided by h. So at this point, I just need to get rid of some stuff in order to have enough space. Okay, all right, let me get rid of the table. So as we are moving on, this is where we stopped. Now we can continue the simplification after getting rid of some stuff. Then we have the y dx to be equals to the limit as h approaches 0 of 1 divided by v of x plus h multiplied by v of x. Okay, then this is entirely multiplied by u of x plus h times v of x. Okay, the minus v of x plus h times u of x, and everything entirely is divided by h. Perfect. So now what I'm going to do next is that I'm going to subtract and add u of x times v of x to the numerator. Okay, I'm going to subtract and add u of x times v of x to the numerator of this expression. Okay, so now we have the y dx to be equals to the limit as h approaches 0 of 1 divided by v of x plus h times v of x, then multiply by some adding and subtracting u of x times v of x. So that's u of x plus h times v of x. So I'm subtracting u of x, v of x, minus u of x, v of x. Okay, then plus u of x, v of x. All right, then don't forget this. This is there. This is just what we have added, and we have to subtract it back to make sure that we are not biased. We are still doing the same thing. So we are subtracting this minus v of x plus h times u of x. Okay, that's u of x. Perfect. Then everything entirely is divided by h. I think I just need to reduce the writing a little bit so that you can clearly see the image. Now this will be equals to the limit as h approaches 0 of 1 divided by v of x plus h, okay, times v of x, then multiply by, now let's combine this term and separate the h along with it. Then repeat the same thing for this term. So we have u of x plus h, v of x, then minus this minus u of x, v of x, then divided by h. Perfect. So I've separated this term. Now don't forget, positive sign is what is connecting them, plus, okay, let me put in a bracket since this is multiplying the entire expression. Okay, perfect. Then plus, we have this u of x, okay, times v of x, then minus this minus v of x plus h, okay, times u of x, then also divided by h, and the brackets closed. Perfect. Now at this point, let's try and factor out common factors between the term we have right here. Now we have the limit as h approaches 0 of 1 divided by v of x plus h multiplied by v of x. Okay, then multiply by the big bracket Now another small bracket. What is common right here? That's v of x, okay? Because v of x is here, v of x is here. So I'm taking v of x outside, then a small bracket, then you have left over here is u of x plus h. Okay, then we have the sign minus the u of x. And close the small bracket and everything divided by h. Perfect. Now plus what is common right here? U of x is here, also u of x is here, you can bring it out as well. So we have u of x, then the big bracket, little small bracket, okay? We have left over v of x, u of x has been taken away. The minus v of x plus h, and close this bracket, and everything entirely divided by h, and the big bracket again. Perfect. So now what I'll do next is that, this is multiplying this entire expression, and this is limit outside them. From properties of limits of product is product of limits. Okay, perfect. So what I'm going to do is that I'm going to distribute the limit for this and for this entire expressions. Okay, then we have it should be enough. It should be enough. So we have the limit as h approaches 0 of 1 divided by v of x plus h times v of x, yes, then times, okay, the limit as h approaches 0. Now for these expressions, okay, that's v of x multiplied by u of x plus h, okay, then minus u of x all divided by h, perfect, then plus this one u of x, then the little brackets v of x minus v of x plus h, and this big bracket all divided by h, and we have the biggest brackets. Perfect. Okay, hope you're following the logic and the steps. Good. Now to have enough space, let's get the one above. Perfect. Now let's continue. We now have the y dx to be equal to the limit as h approaches 0 of 1 divided by v of x plus h times v of x. So now what I will do next, as you can see, this is the limit outside two expressions that are adding themselves. Now from what is of limit again, limit of addition is addition of limits. So I can distribute this limit for each terms as well. Then I have the limit times the bracket is still there times the limit as h approaches 0, then of this v of x multiplied by u of x plus h, then minus u of x, and the big bracket closed all divided by h, then plus the limit as h approaches 0. Are you following? The u of x times v of x minus v of x plus h all divided by h. Perfect. So the bracket is still there. Good. Now, before we begin to plug in what h is approaching, okay, with respect to 0, let's try to focus more on this term. As you can see, it is v of x minus v of x plus h. So now what if we want it to be v of x plus h minus v of x? If we want to do that, what we're going to consider doing is to factor out negative sign. And factoring out negative sign from this will make this to have negative. You understand? Because it's positive before, then when we take the negative sign out of it, we have negative to be left over there. So now we have the y dx equal to the limit as h approaches 0 of 1 divided by v of x plus h times v of x, okay, then multiply by the limit as h approaches 0 of v of x, okay, then multiply by u of x plus h minus u of x all divided by h. So now I'm taking negative side outside. When it comes outside, it's a constant. It will go pass through all the way to this point. It can pass away the limit as well. So that becomes minus. Then we have the limit as h approaches 0 of u of x Now in the bracket, this will now not be v of x anymore. It will become minus v of x. But instead, I will flip the position and I have v of x plus h minus v of x. Perfect. And all divided by h. Hope you are following. Okay. If you have any question, feel free to let me know in the comment section below. Perfect. Now, this is a constant. It doesn't really have any business with the limits. As you can see, the h approaching 0 is not with respect to x right here, but with respect to h. Same thing applies to u of x. We can take them out of the limit, and then we have equals to the limit as h approaches 0 of 1 divided by v of x plus h multiplied by v of x. Okay, then in the bracket, taking v of x outside, you have v of x, the limit as h approaches 0, alright, then multiplied by u of x plus h. I really don't need this anymore. Then minus u of x divided by h. Okay, then minus, this is taken out, u of x. Okay, then we have the limit as h approaches 0. Okay, then multiply by, okay, I said I don't need that, v of x plus h, then minus v of x, all divided by h. Now, as you can clearly see, from first principle, this entire expression defines the derivative of u with respect to x. Okay, that's simply u of x. Similarly, this defines the derivative of v with respect to x. So now, as h approaches 0, we have 1 divided by, plug in 0 as this, v of x plus 0 times v of x. Okay, and everything multiplied by v of x. Now, we said this entire expression becomes u prime of x times u prime of x. Then minus, this is in bracket, minus, then we have u of x. We said this entirely becomes v prime of x, v prime of x. Perfect. So now, simplifying forward, we have 1 over, this is v of x plus 0, that's v of x, times v of x becomes v of x all squared. Perfect. And I'm multiplying that with u of v of x times u prime of x, okay, then minus u of x times v prime of x. Perfect. Now at the end of the day, we have our final answer. Then we have the y dx to now be equals to v of x, u prime of x, okay, then minus u of x, v prime of x, all entirely divided by v of x all squared, which corresponds to the formula I wrote earlier or stated. And this is how the quotient rule formula is formed. In our next video, or in the video I attached to the description of this video, you can find how these formulas are used effectively to solve calculus problem. I hope you find it helpful and understandable. Thanks for watching. See you in the next video. Bye for now.